Press that. Thank you very much, Miriam. Thank you, Biliana, for a wonderful start to the session and for inviting me here. I participated in Oceans Day, and I kind of come to these issues having spent most of my career working on land issues, forests and agriculture. And when I talk about blue carbon, it's actually the land that's as close to the water as you can get. But, and one of the things that really strikes me, and I've been coming to COPs for several years, and I always kind of enjoy what I call hump weekend. You know, between the 2 weeks, we now have Oceans Day, we have Forest Day, and we have Agriculture Day. And I think it provides sort of an interesting set of insights to the fact that climate policy, as broad and comprehensive as it is, it touches all of our biomes, and it can't solve all the problems in the biomes, but it has profound impacts. And so this idea of trying to balance good oceans policy and good climate policy and good forest policy is really a challenge. And I invite you, if you would, to I did a blog post this morning in the National Journal called "You Can't See the Ocean for the Trees," and hopefully there's, in the 600 words there, you see sort of my perspective on kind of trying to solve these problems simultaneously. So Biliana gave a nice overview of Oceans Day, and we're going to hear from the panelists after me about what I would just have to describe as fairly, at least to my eyes, very sobering view of some of the challenges associated with challenges isn't a strong enough word, deep threats associated with continued climate change and continued higher concentrations of CO2 in the atmosphere on our oceans. Because I'm an economist, and we all know that economists are bright, cheerful people, not the dismal scientists that everybody thinks we are, I'm going to try to inject at least a little bit of opportunity in the story in terms of the roles that oceans and coastal ecosystems can play in helping mitigate the climate problem. Next. So, but before I do, it's always a good idea to thank the people who paid you for the work. And so Linden Trust for Conservation has supported this effort, which is really, it's a cross-disciplinary effort between economists and ecologists and natural scientists to try to get at this issue of blue carbon that I'll describe in a little bit. And so we can go on to the next one. Okay, so real quickly, what do we mean when we talk about blue carbon? How many people, before they came into the room, had heard the term blue carbon? That's most people, but not everyone. So let me try my best to describe in about 15 seconds what that is. It's essentially three types of coastal habitats or ecosystems. And again, it's the land that's as close to the water as you can get, and we're primarily focusing here on saltwater. And so it's mangroves, seagrasses, and salt marshes. They are distributed globally, primarily in the tropical and temperate zones. As Biliana alluded to, they have a tremendous impact on the global carbon cycle. Now, in aggregate, not as much as forests do, because there's a lot more forest land globally than there are these ecosystems. But on a per unit of area basis, they can hold up to 5 times as much carbon stored on site, and therefore disturbance of those areas can have a huge release of carbon, and that's contributing to the climate problem to begin with. Next slide, please. So let me, just in case there's a fire drill and we get pushed out of here by the time I'm done, let me just give you the sort of the summary story in 4 easy bullet points. The first is that perhaps is no surprise to you, coastal ecosystems are at great risk. And as I just alluded to, they are significant stores of blue carbon, but they also provide many, many other ecosystem services besides carbon. In that blog post I was talking about, and one of the things, when you study oceans or you study forests your whole career, you can't stand to have it reduced down to the issue of how much carbon it stores, right? But the reality is that at a climate conference, that's what we're talking about. And so, but the reason you want to save mangroves, salt marshes, and seagrasses is not just for carbon, but because of all the other ecosystem services that they provide, as well as carbon retention. Okay, and so the risks to these ecosystems are driven, they're driven by economic pressures to convert them. What's driving these pressures? Well, aquaculture, and particularly in Southeast Asia, there's a big pressure on mangroves through shrimp farming operations and other types of aquaculture. Traditional agriculture, some timbering as well as real estate development. I hate to say, but we're we're in an area that has knocked down a few mangroves to accommodate us here. Well, so the whole point here is that the global climate change mitigation efforts can change that economic calculus by paying for reductions in these blue carbon emissions. And again, as Billy Ann alluded to, this is very similar to what we're talking about and many people hope we get at the end of this week, which is a global agreement on REDD+. Essentially, very analogous story. Paid to not convert forests, pay to not convert these coastal ecosystems. But this is not yet, it's really just a glimmer in the eye of the UNFCCC process at this point. It's about where REDD was, I'd say 7 or 8 years ago. Okay, so our group just kind of looked at an initial test of concept, looking at the science, how much carbon can be stored or lost, restored over time, how much can we avoid by taking reversal action or restoring these systems, and then the economics of it is at what cost, and we do that because we want to see how you would base payments. And then from a policy perspective, can the current policy frameworks accommodate these types of payments, or are new ones needed? Okay, so I guess we had a little blip here, but just real quickly, I mean, here are some representative data that we have on the storage of blue carbon in various types of ecosystems. The brown part is the part that's below the ground. The green part is the part that's above the ground. And some of that is below the water, but it's above the soil level. And as you can see, in the case of blue carbon, most of it is brown, and most of it is below the surface. And the ecosystem that has the largest above surface biomass is mangroves, because those are shrubby trees, but they still have significantly amount more low carbon. And if you compare that to tropical forests, and this is on a per hectare basis, you see that particularly mangroves, and when we take soil into account, are much larger stores on a per unit of hectare basis. And tropical forests are pretty large stores. These are being converted at relatively rapid rates, about 1 to 2% per year over the last 20 or 30 years. Continue. Okay, so real quickly, what might be eligible for crediting? Let me think about this. So first of all, these ecosystems still continue to sequester carbon. That's another contrast with tropical forest ecosystems. When tropical forest ecosystems sort of hit a level of maturity, they're in a steady state, and they sequester as much carbon from the atmosphere as they lose through respiration. But these coastal ecosystems still continue to accumulate carbon below ground almost without end because of differences in geomorphological processes. So that's one thing. Another is the possibility of paying for avoided emissions from soil carbon after these disturbances. And another is avoided emissions from the biomass that's cleared. So when you clear a mangrove, you remove all of the above ground, the woody biomass, and you take out about the top meter of soil, and that goes rather quickly into the atmosphere. Next. So in the remainder of my few slides, I'm going to just give our preliminary view of can the economics work. We're going to have a final report that will be done in about 6 weeks, at which time we'll be able to answer this question a little bit better, we hope. So what we want to do is we want to look at the market value or just the payment value of carbon and compare it to the cost of protection. The cost of protection really comes in two forms. One is you have to pay to protect area. I mean, you need to monitor it, you need to guard it, you may need boats to enforce things. But you also, if you're going to tie land up and try to compensate people not to convert their land to another use, you have to think, well, what is the value of that land in another use? So if you were going to clear it for a shrimp operation in Malaysia and it's legal for you to do that, then what do you need to be paid in order to choose not to do that? And that's what economists call the opportunity cost of land. And we want to take both of those things into consideration. So our quick preliminary analysis is, as most, if you know economists, we're all two-handed, on the one hand, on the other hand. So economics can work in some cases. You can look, what you want to look at is the carbon. So what we do is we essentially monetize the carbon value, and that's not really a hard thing to do. We essentially take the numbers, the stock numbers that we looked at, and we estimate the carbon losses over time, and you assign a payment to those carbon losses that you avoid over time. And the payment that we assign for this particular graph is $20 a ton of CO2 equivalent, which is essentially what carbon is trading for on the European Union emissions trading system right now. So that's why we picked that number. If you translate it from euros to dollars, that's what you've got. Doesn't mean that if blue carbon entered the market in the future, that's what it would trade for, but it's a pretty good proxy for it. So when you look at this diagram, what you see is, well, like in the cases of seagrasses and tidal salt marshes, you see a couple things. One is that's quite a bit larger. The opportunity values associated with those are relatively low, so that economics looks like it should pay. But where the rubber really kind of hits the road is in the area of in the area of mangroves, for two reasons. One is they're greater carbon values, but they also tend to have greater opportunity cost values. Again, shrimp farming is a relatively profitable operation, and so you have to outcompete that. But at $20 a ton, it looks like you can, at least in our rough estimates. And I'll conclude in a few slides and show you that there's a lot more that we need to do to feel more robust about these conclusions. Another take-home message here is the browns and the greens again. The browns again show you what you get paid to keep soil carbon or below ground carbon out of the atmosphere by protecting these ecosystems. Now, one of the things when we look at lessons from red is that the role of soil carbon has not yet quite been determined. And in fact, the focus has been on above ground. And you see with forests, most of it's above ground anyway, so that's where most of the story is. But if you were going to get blue carbon in a payment system and you didn't pay for the soil carbon losses, you kind of knock the economics down. It wouldn't pay very well. So as you start to think ahead about how to do this, you want to make sure that you have good measurement methods, and I think you want to have a policy framework that includes payments for avoided soil carbon losses. Okay, next slide. And then we did a more specific case study of mangroves, and this red bar that you see here is essentially a range of protection costs for mangroves in Southeast Asia. And then we looked at the carbon value at a series of prices from $0, which is what you get now, you get nothing, to $30 a ton CO2 equivalent. You can see we find a break-even price, something in the range of $10 to $12 a ton CO2 equivalent. So again, first order estimate is that the economics could pay for this. Okay, so what's next? We need to continue to work with a scientific team that I identified in the earlier slides to make sure we have the best estimates of stocks and emissions rates available. We've actually made a lot of progress even just this week on that, and we have to sort of redouble our efforts to get more information on economic values associated with opportunity cost, land values, and it's helpful to look at these really important cases of mangroves and shrimp farms, for instance, but we want to extend our results and our findings over a wider range of conditions. So I have some copies of our policy brief giving you sort of our preliminary assessment in the back of the room. Feel free to pick it up. Feel free to contact me if you have any questions. Meanwhile, thank you very much for your attention the last few minutes.